Nice. Welcome, everyone. I heard that the light is the signal for me to start. I think we're 5 seconds early, but let's get to it. It's the session before lunch, so I hope your hunger is like driving your attention now. You want to hear and run and eat. Um, Having a good conference so far, everyone? Is it going good? Nice. So today we're going to look at the history of C Sharp. On the website it says version 1 to 12, but they decided to sort of let us know what's in 13 after I submitted the talk. So it's actually up until 13, the latest version coming out next month. Just to check the room, how many, hands up, how many has worked with .NET and C Sharp for more than 10 years? Great. So you're you're gonna laugh and cry, and everyone else you're mostly gonna laugh because we're gonna go through and just see like all the pain, of course, and the pain we've overcome with joy of C Sharp evolving over all of these years. So just quickly, like this is the C Sharp we like to see. It's condensed. It's you can see your properties and your methods, and it's all there. You read this, you can see okay, it's a record type and it's a named example. I wasn't creative enough. We have a property and we have a method that returns a value based on this. Returns a string based on this value. But if we go back to C Sharp 1, you cannot have top level namespaces. There's no records. You cannot have primary constructors. There's no init. There's no auto assignment of properties. There's actually even no generics. There's no arrow functions to have shorter member bodies. There's no switch. There's nothing of this. All of this is gone. There's nothing like this. And it's quite fun and interesting to look back how far we've gotten. Like this is maybe a very standard type of class nowadays, and this was not possible when we started out with C Sharp. Oh yeah, no underscore, no name of, even. That's crazy. Still don't have it in TypeScript. So here is the Java equivalent, even. Like modern Java. It's a little bit more verbose. There's a lot of private fields and there's no properties. I was about to say for the properties, but there are no properties. There's only functions, as we can see. And yeah, it's readable. You understand it, but it's a lot more verbose than C Sharp. So I like looking at this is ChatGPT translating the other C Sharp class that I told it, like, give me this in C Sharp. This is what it came up with, and again, that made me a little bit like happy on my bet on C Sharp. Yeah, this is the example we looked at. I find that it looks a lot better. So very quickly about me, Sebastian, CTO of the Noga Group, 20 years in tech, software engineering, leadership. Focus on Microsoft ecosystem, .NET, C Sharp, Azure, TypeScript. Passionate about web technologies. And my colleague looked me up on CoderRank and it said that I'm #1 in Sweden on C Sharp. Not sure how it measures it, but I was happy. So short reminder just to take us back, like what is C Sharp compared to other languages, like what is the basics. It was created in 2000, so 24 years ago. But it first was available to the public 22 years ago in 2002, created by Anders Hejlsberg at Microsoft. He's still there. And it was introduced very closely alongside with .NET and Visual Studio. These three, the language C Sharp and the framework .NET and then the tooling in Visual Studio, they sort of evolved a lot over time. Very closely together. And it was initially closed source, so you couldn't like dig into the implementations and see why things behaved the way they did. It was ECMA and ISO standardized back then, and now it's open source on GitHub. And it's cross-platform both in development
which is very handy. So you can develop on Windows and Mac and Linux and deploy also to all of those, web, mobile, everything. So in the big picture of like why is it important to think back on like what C# is, to explain it to someone else. It's multi-paradigm. It has strong typing, imperative, declarative functionality, and functional, generic, object-oriented. If you look up other languages, they usually don't like stretch this wide across so many paradigms, even though many are sort of catching up. Java is trying to do this, and other languages as well. What this allows us is to use the right tool for the right problem, and that is not to be underestimated. There's a new version every year, and it actually addresses like real-world problems. Every time there's a new version of .NET and C#, you know, like, okay, it wasn't a vanity feature that was added. It's something that's used either by us who are using C# or some team at Microsoft that needs better performance or better syntax. So it's a public process on GitHub, and Microsoft is dogfooding C#. That's why it's moving quite quick and well lately. And it's inspired a lot of other languages, as we'll see in the moving through the versions, how other languages has picked up features from C# along the years. Languages like TypeScript, obviously, because it's made by Anders, same person who made C#, but F#, Rust, Java, many more has been very inspired by C# and features in it. But what makes me happy about picking and using C# is that every new version addresses real-world problems. That is very fitting at the time that they're released. So on that topic, like LINQ came out at the time where there was a lot of data manipulation and we needed to do like logic over big data sets. Then LINQ came out, and it's still like an envy of many other languages. I have friends that I talk to who are like, I am super happy now I'm working in Java or Scala or whatever, and I'm like, yeah, but LINQ, and they're like, yeah, you're right, I missed that one, but everything else is perfect. So that's a big one. Async await, something we take for granted now, but it didn't used to be as smooth of a syntax as it is now. Now we even have it in TypeScript and JavaScript. Null propagation, also like, yeah, well, this is basic, but it's not there in every language. It's very new in JavaScript and TypeScript, for example. Nullable reference types, that also like really took a big grip on a big problem that needed to be solved at the time, and gave a lot of people a lot of value. Pattern matching, I think there C# drew a lot of inspiration from other languages. So there it was the reverse, where they could see there are syntaxes for pattern matching that can make your code very readable and compact. Record types filled its function when it came out, being like non-changeable types that are comparable in the way that they are. Generics, something we take super for granted. It was not there to begin with. It was added later on with co and contravariant. Attributes, it's still, I think, not even a real thing in JavaScript. It's like, what's it called? Yeah, preview feature, and it's not there in all languages. And it's something we take for granted very easily to just do meta programming on our code. So why is it so useful and important, these language syntax improvements? So going back to some C# code, if we look at this, what we have is just an example class. It has a constructor that takes in an ID, an ID as a string. It assigns it to a private field, and then you have a public property that accesses this private field. and like, okay, this is fine, like this is code we can read, we recognize it, but if we look at how many times we actually reference just the field that we want, that is the ID count is actually 7 times, while we could do it like this in modern C#, where it's basically one reference where we say this is the ID field and we don't need to duplicate it everywhere. And this is like a very powerful example of how the language evolution makes the language more compact but still readable. You can still reason about this and understand the functionality of this class. Is it visible? Yep. So this was a tweet that came out a while ago where Martin Fowler showed that you can like plus equal a function and then execute the original variable on the last line. And this is maybe an example of like, it doesn't hurt, but some features maybe you should like think about, like, should we really add this? This one makes sense, but there are other features where it becomes a little bit like, maybe not that one. And that's a very difficult balancing act that the C# team has had to take along the way. Like, what should we add? And once it's added, they don't remove features from the language. So yeah, let's dive in. Walk down the memory lane a little bit, look at each version along the way, where it took us, where we started, and where we're at right now. Get a little perspective on the C# evolution over time, starting off with then version 1 and 1.2. It's called C# 1.1 some places and 1.2 in other places, and I think it's because the .NET framework was 1.0 and 1.1, so there was a little confusion around that. But if you're looking at C#, the initial versions, and you put on your glasses, it was like a very, very similar to Java. It was sort of, some people would say a clone. There's some other features in C# that is not in Java, but it was extremely, extremely similar. So let's jump into some C#. Just a quick refresher of what we actually had in version 1. Like, now I've actually set the project in Visual Studio to be version 1 of C#. So like these are all valid syntaxes. We had all the primitive types that we're used to, int, string, char, bool, and all the other numbers. Value types with structs and enums. We had basic or the same objective-oriented programming we have today. We had, namespaces to structure stuff, classes, method overriding, interfaces from day one, inheritance, virtual methods, and the objects, obviously, that we instantiate the classes with. They were the same try-catch error handling we have today, a little bit less refined. It was all there in version 1. We had reflection, very underrated from day one. Still not there in TypeScript, probably not possible. We had attributes from day one, properties, which Java chose not to have, delegates, events, multi-threading, out of version 1, garbage collection, obviously very, very central. So that was quite a extensive version 1 after all, but it was missing some things. So that was released in January 2002, and it actually took 3 years for Microsoft to produce the version 2, which in my mind was the sort of the ready-baked version that was really okay, now we're talking. The tooling was great, the language started to mature, and it was really useful. So .NET Framework 2 and 3 was released, and a new version of Visual Studio. You're gonna see that in the beginning, every new version of .NET and C# came with a new version of Visual Studio. Yep. So let's look at what we got in C# 2. It's going to be quite heavy in the beginning with a lot of features, and then it sort of becomes less and less over the versions. But yeah, November 2005, we got generics. We got nullable types where int and a bool and other numbers could actually be nullable. They could not be that at all. You had to do a lot of magic before that was possible. We had iterators where you can just like yield return in the middle of a method, a function method in C#, a method flow, which was quite powerful. We got getters and setters that were not always only public, so we could get private setters and public getters. That was not in the first version, which is crazy. We got partial types, also not there in the original version, and a lot of features is built on this, so it's kind of cool to see how early it came in, and then they built on top of that. And this one actually was one of the surprising thing for me, that we actually didn't have static classes in version 1. That was introduced in version 2. 2 years after that, a new version of the framework of C# and a new version of Visual Studio came out, which was C# 3 then with .NET. It worked on .NET Framework 2 and 3, but it was missing a key feature that we'll look at. But 3.5 was the mature, or the final version, I would say, for C# 3. And this one was a good one. We got the auto-implemented properties where you don't need to fill out the full method body like this, the return and setting. You just said like, okay, I have a getter and a setter, and you will create the backing field for me. We got the var keyword, which I like a lot. You can come fight me afterwards, after the talk, but it makes a lot of things easier. We got anonymous types where you can just new up an anonymous type that is not a class that you already declared. We got lambda expressions, something we take a lot for granted nowadays. It was not there before version 3. And we got expression trees, which then sort of wraps these functions and can give you metadata around the expression you're using. We got also the object initializers, where you can set properties in the constructor of creating a new object, which was a good shorthand. And we got extension methods. So now we've added like a lot of features we take for granted, a lot of basic features that a lot of future functionality will depend upon. But the magical thing about C# 3 was LINQ, and it sort of makes C# very much into a hybrid, object-oriented and functional language, and enables you again to use the right tool for the right problem. It enables these declarative queries that you can read and see very, very clearly like what they're doing, and it's constructed on top of these new language features that were added, the lambda expressions, the expression trees, anonymous types, and extension methods as well. And it was a massive, there's been a massive performance improvement in the last versions of C# in the last few years to keep it at top speed. And this has definitely inspired a lot of other languages. So if we have a LINQ example here, just very easy. We want to get the latest names of all the people, entities in our database. We first take out find the repository for people, and then we order by descending. We want the latest ones. We filter on the where over here. We want only the active users. We want to only take the top 10, and then we want to use the name of the person, and we don't want any duplicate names, and then we materialize it by toListing or toArraying this method. And like this is, you can really like read line for line. Okay, what am I getting? What was the order? Oh yeah, okay, order by. Okay, and what am I filtering on? Oh, it's there. Like it's very, very readable. And like Rust is very similar in that way, where you get your collection, you sort by, they use the pipes instead of the arrow. It's the same idea, but they like as compact syntax as possible. But here's the same thing. We do a sort by, created at, we compare it to A against B. We filter on the active. We take the top 10 and we map and take out the name, and then we materialize it into a collection. So you can see that it's very inspired by LINQ, obviously. Java, that's another story. So here, this sort of like visualizes really like what is, okay, so we take LINQ for granted, but like don't do that, because this is how it looks without LINQ, where we get the people from the people repo, but then we have to create a new array up here to hold all the active people. We loop all the people. We do an if statement, and if they're active, send them into the array, and then you sort this array, and you have a comparator, and to look at the created at and compare to, and it doesn't end, it continues, and then the top 10, you just do a 10-time loop, and you add the top 10 from the from the active people into that array, and distinct, you use a hash set, okay, makes sense, and add it all over, and then to array it all. And to be honest, like this is not as fun to read. You can understand it, and this is probably sort of what's going on behind the scenes in LINQ. But seeing this makes me very happy that we have LINQ, where you can just see like 5 lines of code instead of whatever that was, 20. So we move on in time again. We have C#4, we have .NET Framework 4. Still numbers of, or the version numbers are aligning. We have Visual Studio 2010, and we get some new stuff in there. So we get the dynamic keyword, possibly one of the few features that I'm like, can we maybe turn this off? But it's good for the purpose that it was created for. It was created for very complex, dynamic, unpredictable objects, or mainly created for that, objects that were used in interoperability with Office, like Microsoft Office APIs. So it served a purpose back then, and it was probably super good for that purpose. But right now, I struggle to see good scenarios for it. We got the named and optional arguments, where you can specify, like if you have 2 strings, like we do in this, maybe we wanted to send in the second maybe we wanted to send in the second parameter instead of the first one, and then we can just say, well, I'm trying to fill this field, and then we have these default arguments where we say, if I don't get the name, just use an empty string, and when I give you a bool, I mean this, so you can refactor and not have collisions. We got the co and contra variant generics. So we had generics, but you could not do it like this. Like I have a list of the base type, and now I'm creating a list of the actual derived type that is inheriting from the base. That was something that was added, and you can specify in which direction you allow your type to inherit. So yeah, not a lot of features, but like at the time, well needed. Someone needed it. So then we wait 2 more years, and we're not going into .NET Framework 5. We get 4.5, but we get C#5. Still a new version of Visual Studio. Every version of .NET so far. It's almost like Microsoft was selling Visual Studio licenses. C#5. Not a lot of, like, all versions got a lot of features when it comes to listing them all, but I'm trying to sort of just highlight the ones that are language features that you can see, not like small optimizations behind the scene, but really things that that is useful in your everyday work, and the perspective hopefully gives you some thankfulness for the latest versions of C#. So before C# 5, we did not have async await, where you can just say like, okay, validate, you move away somewhere, you call a database or whatever. We can hide this and pretend it's a database call, and you await it, and it's performant, and you can handle async functionality in very complex and predictable flow of your code. And this is very good to compare to the old way, where the pattern of doing things async was actually this. I looked up some old code where you had to have like a async result and some kind of a validator that begin, like the validator is my class, but the pattern was that you begin validate and then you send in a reference to a function that is called when the awaiter is done, and then it's just like really hard to read syntax, and you know that this outer function, the validate sync, will run through the whole thing, but at some point this callback, the validation complete, will call, but at some point, so you cannot like do a try catch, you cannot like in the same flow, you cannot catch when that happens, you don't know when it happens. So yeah, this was not super fun. Like I even had to comment out code because it was just breaking. Yeah, so this is what we got away from. Very good. C# 6. Yeah, now they're keeping the minor versions in sync with the C# versions. Now it's .NET Framework 4.6. But it was also the first version of .NET Core came out in this time in 2015, .NET Core 1 and 1.1, new version of Visual Studio, still going strong there, but we also got VS Code, the first early versions. And yeah, here was actually another sort of a jump in new productivity syntax, I would say, to shorten down your syntax of a lot of patterns that maybe was identified as like, okay, this is a lot of repetition, and this is a lot of yeah, we're doing the same thing all the time, like the null propagator, where the syntax was always like if name yeah, if name.length is not null, then take the length. Like it was always the same pattern that you wrote. So that was a very good one. And the name of, like super performant, done on compile time, takes whatever in here and makes it into a string. So it survives refactoring and things like that. Extremely powerful. Again, not in every other language. We got the string interpolation, where you can just like have a long string or have a string and then just interpolate and insert values from variables into that string. Instead of doing the string plus value plus another string plus another value. This is a lot more readable, and again transferred to other languages, and like probably was in some other languages as well. We got the auto property initializers, where you can, like on the same line, if you wanted a default or a first value on a property, set it on the same row. This is very undervalued. This was before this, you needed to create a whole constructor and just set the default value in the constructor, which didn't, like, it was 3 lines of extra code that didn't really it kept the logic far away from the implementation. So if you didn't see the constructor, you would miss that the default value was set in the constructors. This is like keeping the truth closer to the actual usage. Expression-bodied members, like if you have a very short or one-liner or function, you can just use the arrow, and whatever's after the arrow is the same as a method body. Again, just shorter syntax, more readable. Yeah, this one is a good example here of it can be used on properties and functions. We got exception filters, the first version of them, where you can not just catch exception as a base type, but you can actually specify and have different types combined with the when with the when statement. So I think this feature was included to do sort of this exact filter where you want to match like a HTTP error from a client, and if it's a 400 error, you cannot find it, then you should act one way. If it's a 500 error, the server is broken, then maybe retry. So it enables those scenarios very tightly. And also, like something not really related to C# as the language we write, but as an ecosystem and as the tooling became better, we also got the compiler as a service, Roslyn. And now the C# compiler is now written in C#. I still cannot like understand that inception, but that's what they said, so I think that's correct, and it's really cool. And then came a long wait again, 2 years, and then a long line of different versions on the 7 version of C#. This was like the first time since version 1 that we got a minor version or multiple minor versions. We got .NET 4 4.7 in the framework, new version of Visual Studio again, but then incrementally we also got, with C# 7.1 we got .NET Core 2 starting to mature. We got version 7.2 of C#, no new .NET versions, and then we got 7.3 with sort of the mature version of .NET Core 2 with 2.1 and 2.2. So let's look at what that gave us. It gave us tuples and deconstruction, where we can deconstruct objects and get like two values out from one type. We got the discard with the underscore. The underscore used to be sort of a pattern, a best practice, where you just say, okay, if I write underscore, that means that I don't handle this value. But now it actually became like a feature that is in C# that just means I know there's a value here, but I'm gonna ignore it. We got the first version of pattern matching. It was quite like rudimentary to what it is today, but a lot happens in 7 years. So you could like check the type and some basic casting, and then assignment of the cast version. So if all of this goes through, then the length, the if statement is true, and you can use the length inside the if statement. So also shortening of syntax. We got the throw expression, where you, instead of having to look first at the argument coming in, saying like if the argument is null, then throw the null reference argument. This is like assign the arg, but if it's null, then fall into this throw. So it's a little bit of a shorter syntax as well. Yeah. We also got the local functions, where you have a function inside a function which can share the state. So we get the arg coming into the outer validate, and in the local function we can still access that arg. Very JavaScripty, but I'm sure that it serves its purpose. C# 7.1, because of all of these versions, I'm guessing it got the LINQ version setting inside the CS project files, so you can switch like, okay, I want the language version 7.2 or 7.3, because if someone opened a project written in 7.3 and they had 7.0, it would clash, and they would not get the behavior they expected and the functionality. So we also got async main method, where the entry point of the whole app was async, so you don't have to do magic to get into an async context and start doing async await. We got private protected access modifiers that helps you scope your members even more narrowly. And C# 7.3 a lot of stuff was done to enable safe code to be as performant as unsafe code, and this was sort of the start of where we are today, where C# can be extremely performant, not just by default, but a lot of constructs that you can use to squeeze every little performance drop out of it. And this just caught my eye. Open source software signing of assemblies in compiler sounded cool. But yeah, as you can see, just small increments. Moving on to version 8, new version of Visual Studio, of course. But this came with .NET Core 3 and 3.1. And now, like in this era, there were some explicit themes that started and probably has partially survived until now. And my guess is that it was very inspired by Node and Rails and other ecosystems where you can just do like a new index.js and then write 3 lines of code and then just run Node in your command line, and it just works. And C# was not like that. It was very or .NET in general, like you had to create a new project, and there was a lot of ceremony to just get the first hello world, or if you wanted to test out a few lines of code, it was not that quick. So they wanted to remove ceremony, separate data from algorithms, and provide more patterns in more places, so make the code even more condensed and more terse. And there was a lot of, and it's been since then, a lot of work on the performance on the .NET runtime. Every year there's a new blog post coming out saying like this is how much performance we saved within every area of the .NET, and it's usually quite impressive. From version 6 it really started to be like a lot of improvements with big numbers. So C# 8, first major version to specifically target .NET Core. We got the nullable reference type, which is a weird name because what it does is make sure that everything that is nullable is not null by default. So if you don't specify the question mark, then you assume that the string will not be null. It's a great feature. We got the null coalescing assignment. Not sure how many use it, but I've had it used in a few lines of code. We got the indices and ranges with the dot notation and the little hat. We got read-only members, which I have commented out because no matter where I looked or which chatbot I asked, I could not really get it to work. But if you tag members read-only, the compiler will optimize even further because it knows like, okay, this is a static result coming out. We got the automatic using declaration. Before we had to like scope where a using started and ended. So we knew like, okay, the stream, you need a parentheses. So before this you needed to say, okay, I'm using this, that's a iDisposable, and it starts up here. I know that after this line I can dispose of it. But what the .NET guys and the C# guys realized was, well, we can actually see in the code that this variable is only used to this line of code, so we can actually do this for you. And this is maybe the most like discussed and maybe controversial feature, but it was necessary at the time and still is, which is like default interface methods. Which means that you can actually in an interface say, okay, or it was used to be able to introduce new members into an interface and then also give it like, okay, if you don't implement or override this interface field, here is the actual method body that you should use, or here's the implementation that you're going to use, and that sort of like breaks what an interface is conceptually, but it was needed for Microsoft to version forward a lot of interfaces. Okay, let's move along. .NET 5 came out. The 1 year later, in 2020, with C#9, and this is where Microsoft committed to, like, okay, there's no more .NET Core. .NET Core is the future, so we'll just call the next version of .NET Core .NET, and it was .NET 5. It's not framework, it's not core, it's the new one. No new Visual Studio version. We got these top level statement where you don't need the static void anymore. So like I said, node style, you can just write your code in the outerest scope and it will be treated as if it's the static void main to get you up and running quickly. We got the record type. We got the init-only setters that can only be set when the object is created. And we got a little bit of more extended pattern matching with the and or keywords. So not a big difference, but still like sharpening the corners. Then we move on to .NET 6, and now we're into this cadence of a new version of .NET every November, which was already tradition in version 2 and 3, but now it's back. So every November we get a new version of C# with a new version of .NET. And now we, after a few version breaks, we get the latest version of Visual Studio that we are using today. And in the C# language, not too much. We got the global using directives. We got the file scope namespace declaration, again in the same, I think it's in the same vein of the compacting the syntax, and like you don't need another indentation for your whole namespace. It's just there at the top of the file. No need for more brackets. And the classes and records are at the top level of the file. And we got the record structs. That is a reference type, unlike the regular records. We're closing into modern time. 2022, .NET 7, no new Visual Studio. We're running towards the future. We got the raw string literals, the triple quotes. That means like until you see a triple quote again, just everything is a string, like you can do anything. And I think, in a way, unfortunately, I think interpolation, no, not sure. I read about it yesterday, but this is a way to really be like, okay, now we're a text, stay in text mode for large pieces of text, or something that, like a JSON text that doesn't really, it needs a lot of encoding of quotes and stuff like that, which is not needed here. Here you can have just an inline quote. We got some list pattern matching, very basic. Like if you have a list that looks like 1, 2, 3, you can match that list looks like this 1, 2, 3. I'm not sure about the super useful cases, but it was added and extended along the way. We got the UTF-8 string literals, where you can actually suffix a string and say, okay, this is not the default UTF-16 that is in C#. This is a UTF-8. We got a required modifier, which is very useful, where we used to have to force through a constructor, like you need to pass this value. Here you say, okay, you can pass it however you want, but you need to set the ID when you create this type. We got generic attributes, something I had some fun with along the years, where you can actually use now, finally, generics in an attribute. It took until 2 years ago to make that possible. 20 years it took. So you can use like a generic attribute with whatever type you want. And then worth mentioning, we got generic math, where numbers got a commonest lowest denominator. So if you have logic around different types like doubles, floats, bools, not bools, ints and longs, you have a base type that you can work with on all of these types. Okay, current version out now, true for another month. .NET 8, C#12. What did we get? We got the alias of any type. Do not use this exact example, but what you can do is say like, okay, when I say type string list, I actually mean a list of string. Like don't confuse your colleagues with this, but there are times when this can be useful for refactorings or whatever. We got the primary constructors. Still a little bit debated on the implementation, since like the casing and the accessibility through the different parts of the code. Might see improvements there. We got primary constructors for records as well. We got collection expressions with these brackets and the dot, which means like take the whole list 1, put it here first, and then fill with 4, 5, 6. So list 2 is 1 to 6. And we finally got optional parameters in lambda expressions, where you can just say, okay, we have these the lambda with the ID and the bool, but if I don't provide it, it will be defaulted to true, which is something I like struggle with, or not struggle, but I've had situations where that would have been really nice for, since lambdas came out a long time ago. So, .NET 9 coming out next month, C#13. What will we get? You won't see it in the editor because I don't have preview bits on my computer. We get the params collection. So if you put params and then some kind of collection type and then the name, the compiler will like optimize around and convert whatever values you push in to make it into that type. So here we have the usage where we just put in 1, 2, and 3, either as an array or as just parameters to the method. And if you do the first type, it will cast those 1, 2, 3 into a read-only span in the way that .NET knows how to do it the best. We got a new lock object. We used to do locking on just a regular object, just a system.object. Now they have a lock object which both signals intent a lot more than just an object saying I'm a lock, and there is some optimizations I think around it as well. There's a new escape sequence, not sure what that's good for. I'm not deep enough in the console, but \E. So we go to the and beyond part, to version 13 and beyond. Something that used to be in my presentation but didn't make it into version 13, but probably will be in version 14, is extension types, which is like extension methods, but on anything. And the first version was only on, I think, properties and methods, but they were discussing to extend like basically anything. So we'll see what the scope will be in C#14. But here, if we have the person type that maybe comes from another library, you want to like override or add a static method to that type, create employee, which always knows, okay, my company name is this. You hide it all behind this extension type, and then you know that, okay, you will get the result you want. And there might also be a shorthand property setting so that you can access the field keyword for the backing field of automatic properties. Feature proposals out there, dictionary expressions. The list expressions are very like condensed and nice and readable. Why do we not have that for dictionaries? Probably coming in the next version. Null conditional assignment. Could be scenarios where that is good. If there's a item in the array at index 1, 2, 3, then set it, otherwise just ignore it. Null conditional await, not sure, looks good, probably some super deep scenario where that is very valuable. And yeah, some nullable constructor analysis, so the compiler can see in the constructor while you write your code, like, okay, you're trying to access a type that is not yet initialized, and give you some warnings on that. Read-only locals and parameters is also in discussion. Partial properties, not sure how they would look, but it's also proposed. Let's skip that. We're running out of time. So some things that I would like to see, just completely speculation. This has nothing to do with anything proposed, but like from my experience, from using like Rust, it's a really nice feature that variables are actually read-only by default. You can only assign them when you create them, and you need to like write a mutable keyword to say, okay, I'm going to change this value later on. That would be nice. And how would that be possible? We would break everything, but we already have like project level configuration where you can add and enable and disable features. So maybe that would be a way to do it, but yeah, it would be discrepancies across many code bases, but yeah, you can dream. Automatic configure await, like just, yeah, we don't want to deal with that. Always async main, maybe remove the need for task of T and only use T. Complete just dreaming of a future scenario. And of course, like XML literals, VB.NET has it, why can't? No, I'm just kidding. It's a bad example, and that's an example of like, you can take it too far. Like, and sometimes you introduce stuff that maybe shouldn't be there, and in C# they chose to not go with this, and it seems now that, yeah, okay, that was probably a good choice to not bloat everything with that, and that's the complexity of all of this. Like, when should you add, when should you remove? Microsoft never does that, but yeah. So I see a bright future for C#. The language will continue to evolve. Real-world problems will be addressed. It's a strong and proven language governance. Like, it's not just either one tyrant or everyone can just add what they want, Scala. And the language will continue to work on multiple platforms. So thank you. Out of time.